couple of these together straight from your homework. Again, this is page 346. This is number 1. Now, the instruction here is to factor. So, I know you guys are looking at this thinking, dang, that's huge. Not only that, it doesn't have just X's. It also has A's, B's, Y's, and Z's. What the heck? Insane. Insano. And there's not even 4 terms, there's 6 terms. So, let's look at this. Is there anything in common in all 3 or in all 6 terms? Or the AX, AY, AZ, BX, BY, BZ. There's not even A's in all of them. But what do you guys notice when I look at these terms? The 3AX, 2AY, AZ, BX, BY, BZ. What do you guys notice? Okay, there's too many variables.
No, there's 2 variables that connect.
Oh, okay. There's 2 types of variables that are
Like AX, AY,
AX, AY, AZ, AAA. Perfect. So you notice that there's an A in common at the very least in these first 3 terms. How about the second 3 terms? There's a B in common. So what does that kind of make you feel like doing? Factoring out an A from the first group and factoring out a B from the second group. So let's exactly do that. Let's pull out a single A from the first group. And what do I mean by group? I'm talking about these first 3 terms. All right? So if I pull out an A from these first 3 terms, what will I have left? 3x plus 2y minus z. You guys got it? So we pulled out an A from those first 3 terms from the first group. What could we pull out from the second group? A B. So we're going to pull out a positive B from the second group. And what would be left in the second group? When I say second group, I'm talking about these guys over here. If I pull out a B from that first term, what do I get? 3x. Okay, so this is what I have left over. 3x. And then what? Plus 2y. And then? Minus z. Okay? So when we look at this, in a sense, we're factoring by grouping. We split it into 2 groups, and we pulled out what was in common in the first group. We pulled out what was in common from the second group. And now we could take a step back and realize, hey, there's something in common in the first group and the second group. And it's that trinomial 3x plus 2y minus z. It's right there also, 3x plus 2y minus z. So what am I going to factor out of both groups? The 3x plus 2y minus z. I'm going to pull them out. Does that make sense? So let me do this. Let me zoom out a little. Make more space. And I'm going to pull out this 3x plus 2y minus z. I'm going to pull it out. And what will I have left over? What do I have left over? A plus B. Oh yeah, I forgot to close parentheses on the first one. Thank you. So, not only that, we're not going to leave it exaggerated like this. Let's write it the way it's supposed to be. Ta-da! What do you guys think? It's easy. Yeah, that's what I like to hear. So number 5 on the homework. No, number 3 on the homework. We already did number 1. If we go back to number 3, we have a 2x to the third plus 5y to the third. Now, ladies and gentlemen, what you should be thinking is sum of 2 cubes. However, this 2 and this 5, they're not perfect cube terms. So you can't really do it at all. There is no GCF to pull out. The 2 and the 5 have nothing. I mean, you just can't do it. It's not factorable. Now, on this section of the book, if it's not factorable, they ask you to write the word prime. Prime. So number 3, the second question on your homework, the answer is prime. That simply means not factorable. If it were an equation, yeah, you wouldn't be able to get answers to this. It's not factorable. Not able to factor. Number 5. Any ideas? What do I do? What are you always supposed to try to do first? What are you always supposed to try to do first when they ask you to factor? Pull out like terms. Factor out the GCF. What's the GCF on this guy? 12Q. What would be left? W to the what? Cubed, all right? And then minus Q. Just Q? To the third. All right. Now, could we do anything else? Yes. You could apply the difference of two cubes formula, right? Because right here you have a perfect cube term, right here you have a perfect cube term, and you don't even have to think about it. The W is your A value, the Q is your B value. You remember that? So the first part will be the 12Q is just going to come down. Then you're going to have a binomial, and then you're going to have a trinomial. So what's the binomial going to be right here? Using the difference of two cubes. It's going to be what? W minus Q. That's easy. If you had a minus sign, it's going to have a minus sign. Whatever term that is, W minus Q. And then you go for your trinomial. What's that first term? W squared. And it's not like you have a number. You can't do anything with W squared. You just write it. And then your middle term is A times B, which is simply W times Q. And it is positive, because if it started out with the minus, this middle term is going to be positive. And of course, the other squared term is always positive also. And what's the other term? It's Q squared. Ladies and gentlemen, this is your final answer to this factoring question. That's your final answer to this factoring question. Okay, guys, now it's time to jump to the new and even more fun stuff. Ladies and gentlemen, take your notes that I handed out and let's flip that paper over to the blank side of it. And let's write down the sum and difference of two cubes formulas. Okay, and those are up in the front right-hand side of the classroom, right there, the board. It says right there, sum of two cubes, write down that formula. Difference of two cubes, write down that formula. I'll write them down right here also. The sum of two cubes formula. Sum means add, all right? So we're going to be adding two things. And what are we adding? We're adding two cubes. So if you have like A to the third power, that's A cubed, plus B to the third power, that's B cubed. Now, that's what it is, but the formula itself is going to be a binomial times a trinomial. So I'm actually going to write it right here. The binomial will be A plus B. And the trinomial over here, it's going to be A squared. There's going to be an AB right in the middle and a B squared at the end. You're going to have to memorize this. And let me tell you this right now. If you started off with the plus, then the middle sign is going to be a minus. And obviously, A squared is positive, and B squared is always going to be positive also. You could think of it in the sense that if you square something, the answer is going to be positive. So you could always put a plus right in front of your B squared. And once again, to help you memorize this with the signs at least, if you had an A cubed plus B cubed, it's going to start with the A plus B. Let's compare this formula with the difference of two cubes formula. So the difference of two cubes formula is going to be when you have the difference, which is subtraction, of two cubes, A cubed minus B cubed, right? Now the formula itself is not that, but it's actually the binomial times the trinomial, okay? Now, just like up here on the sum of two cubes, if you had A cubed plus B cubed, you start out with the binomial A plus B. So guess what's going to start out with right here? A cubed minus B cubed is going to start out with what? A minus B. That's right, A minus B. Okay? Now, what about this trinomial over here? It's going to be the same exact trinomial as this. It's going to be A squared, it's going to be AB, it's going to be B squared. And just like up here, the A squared is always positive and the B squared is always positive. The only difference is if you started out with the minus sign here, then you're going to have the opposite sign right here, which is going to be a plus. So keep that in mind. That's also true on this above formula. You started out with a plus b, so this middle sign has to be a minus. Right here it's a difference, so you started off with the minus, this middle sign has to be a plus. So we have to memorize these guys. So let's go through a simple example. We'll put these formulas over here. Now let's say I had something cubed. Let's go with the x cubed, yeah? And let's say, do you guys want it to be a sum or difference? Pick one. Difference it is. X cubed minus, now give me a perfect cube term. 9? No, it's a perfect square term. A perfect cube term. 8 is a perfect cube term. 27 is a perfect cube term. 64 is a perfect cube term, right? So let's go with the simple one, 8, all right? So let's say you had x cubed minus 8, and let's say they told you to factor. Okay? Now, could you pull out a GCF from here and here? No, there's only two terms. There's x's here, no x's there. There's no number here, there's an 8 there. So you can't factor out anything until you know this formula. Because you need to recognize, hey, this is a perfect cube term. 8 is also a perfect cube term. However, you can't see the power of 3 yet. So the very first step would be to write it as x to the third minus what to the third? That 8 becomes a what to the third power? 2 to the third power. So this is your first step. Now, why would I want to rewrite this to look like this? I want to do that so I could actually see my a and b term right here. My a and my b, I could see it. My a is x. My a is x, and my b is 2. All right? So now we could use the difference of two cubes formula, because now we know that your a value is x and your b value is 2. Number one mistake that students make at the beginning of this is they call b 8, and 8 is not b. 2 is b. So it's very important that you rewrite this to look like this so you could identify your a and your b. And now we could apply the formula. So the formula will be a minus b. So what am I going to write in the binomial? Instead of a minus b, what am I going to write? There you go, x minus 2. And now for the trinomial, this does take a little bit of work. Instead of a squared, it's going to be what? X squared. And we have a plus a times b. Well, that's going to be a x times 8, and we could rewrite that as 8x right now in a little while. Oh, wait. Yeah, I was just checking to see if you guys are paying attention. Good call. B is 2. And for the last one, b squared, that's going to be plus what? 2 squared. Okay, so of course we could simplify. Let's simplify. So we're going to end up with x minus 2 as a binomial, x squared plus 2x plus 4. Now you might think, oh, this is a quadratic trinomial that I could factor by doing the parentheses and x, but if you think about it, you can't do it. It's not going to work, okay? It's not going to work. So this is completely factored right here. Now, once again, why would you want to be able to do this? Because if this original expression would have been an equal 0, then you could take this and set it equal to 0, take this, set it equal to 0. Right here, you'd get the answer 2, and over here, you could use the quadratic formula for A, B, and C to be able to find out your two answers from this quadratic trinomial.